let's get started. Hey everyone, thanks so much for coming here today. I'm James Cadella. I'm a product manager in Azure Cosmos DB. And today we're going to talk a little bit about serverless generative AI applications and building scalable RAG apps with Azure Cosmos DB. So we'll start off, we'll talk a little bit about Azure Cosmos DB and some generative AI use cases. We're going to hear from Bhaskar Bhatt, who's a global product lead at EY, on how they're using Cosmos DB and Azure AI to build a powerful platform for EY and for their customers. And then we'll also talk about some of the new features that we're launching for search and AI applications in Cosmos DB. And then we'll see a couple demos along the way. So at Azure Cosmos DB, we're building the universe's best database to build your AI applications on. Scalable, performant, extremely cost-effective, and flexible. We have a few different flavors of Azure Cosmos DB. So today, primarily, we're going to talk about Azure Cosmos DB for NoSQL. In Azure Cosmos DB for NoSQL, we have a few different models. We have a serverless model, so you pay for compute, and you only pay for what you use. We also have a provision throughput model where you're paying for compute per time unit, right? So request units per second. And in a provision throughput model, you can take advantage of our instant and dynamic auto-scale capabilities. Azure Cosmos DB will scale outward for you automatically as your data volume grows or as your traffic requirements increase. Cosmos DB is known around the world for low latency, real-time data transactions. We have an SLA of under 10 milliseconds for 1 kilobyte point reads and writes anywhere in the globe. We also offer mission-critical reliability. We have HA scenario for up to 5 nines of availability. In Cosmos DB, it's a document store, right? So your data items, you can think of them as JSON documents. And so you can store your data and your vector embeddings for your AI applications together in the same document if you'd like, right? And this is really powerful. We'll talk a lot about this later on, where we have a built-in vector indexing and search capability in Cosmos. So this removes the need to have a dedicated vector database and ETL your operational data from Cosmos DB to a vector database, right? I can keep my data and vectors together in one place, keep my data in sync, and run efficient operations, whether they're traditional CRUD operations or vector search or text search operations, as we'll see later, all in Cosmos DB. And this is powered by a state-of-the-art vector indexing method called Microsoft Disk ANN, and we'll talk about that as well. Now, we also have another flavor of Cosmos DB, vCore-based Azure Cosmos DB for MongoDB. And my colleague, Ze, here will talk a little bit about that.
Thank you, James. So this service is called Azure Cosmos DB for MongoDB. It's for MongoDB users. It's vCore-based. And it allows to seamlessly migrate to Azure Cosmos DB from existing MongoDB without any change of query and data schema. And it supports separately provision the compute resource and disk storage. And also, it supports separate scale up or scale out of compute resource and disk storage, which is quite flexible. And it provides better control over resource allocation according to your workloads. Additionally, it supports storing data with vector combined together, ensuring the data consistency and real-time vector processing together with ground truth data, which is essential for Gen AI application scenario. While you are using Azure Cosmos DB for MongoDB, it naturally brings lots of enterprise features, such as HA, GeoReplica, and various vector index type support, as well as using Azure OpenAI to generate embeddings in database backend, so on and so forth.
Yeah, so there's really great options for Cosmos DB regardless of what your preference is, right? So Azure Cosmos DB for NoSQL, we'll talk about more. If you're curious about vCore-based Azure Cosmos DB for MongoDB, there's actually a session on this, on lowering the TCO of your MongoDB workloads using Cosmos DB. Tomorrow, I'll have details later on in the slide deck. So for Azure Cosmos DB for NoSQL, I mentioned that there's a serverless option. We'll talk a little bit about that real quick, right? So Cosmos DB serverless is extremely cost-effective and very flexible, right? You can start simply. It's very easy to set up and configure. It's easy to manage, right? One of the main value props of Cosmos DB, in addition to its scalability and SLA for low latency transactions, is you don't need to manage the database, right? We automatically shard and partition your data for you, so you don't have to worry about that strategy. As a very low cost, So for about 1 million request units, it costs about 25 US cents. And again, you pay for just what you use. So if this is really great for multi-tenant applications, applications where you have unpredictable traffic or maybe low average traffic, and also really good for development environments as well. And of course, Cosmos DB has integrations with other serverless capabilities in the Azure stack, including Azure Functions and Azure Container Apps.
As we move into the era of AI-driven innovation, the role of database has significantly expanded beyond traditional data storage and data retrieval. So what's the difference and the benefits of using Azure Cosmos DB for AI scenarios? First, combining operational database with vector database, it eliminates the needs of ETL data into single purpose of vector database, reducing the complexity and the cost. Second, building RAG pattern application gets easier, and it allows you to personalize your large language model, and it's faster and more cost-effective than fine-tuning. By combining context across conversation, it can make the most of large language model and help get the most optimized result from large language model. Semantic catching can help drastically reduce the latency and the token consumption, as well as the cost of large language model usage. Agent-to-agent communication, logging, and transaction handling, it can help ensure the reliable AI workflows. So as we can see, lots of customers are using Azure Cosmos DB to build their powerful AI solutions. OpenAI relies on Azure Cosmos DB to store all their transactions and user interactions across more than 40 workloads. OpenAI has been growing at a drastically rapid pace since its launch, which requires the seamless scale with zero downtime, consistently high performance and availability, as well as the fast iteration on data shape. Azure Cosmos DB enables OpenAI to solve all these challenges and meet their needs of fast growth. So like OpenAI, if the customer use Azure Cosmos DB, they can easily combine other Azure services to tackle complex real scenario problems and get benefits from its rich feature sets as well as its high performance and scalabilities.
Yeah, ChatGPT is a really great use case, right? So they're able to scale seamlessly with Cosmos DB from the time when they had very few customers to now, they're extremely large customer set, as I was talking about. And they do this today, by the way, in just using one Cosmos DB collection, right? We scale out automatically to thousands and thousands of partitions for them and manage that automatically. So now I'd love to invite Bhaskar Bhatt, the global product lead from EY, to come up and talk about the AI development that they're doing on Azure, powered by Azure Cosmos DB. Bhaskar?
Thanks, James. Hi, I'm Bhaskar Bhatt. I'm a global product lead at EY, and I specialize in data and AI. I'm based out of EY's London office. So EY and Microsoft, they have been working for quite some time in building products and services, especially for our merger and acquisition practitioners, as well as for our clients. So I'll play a quick video to give you a preview of our vision. And then we'll take a deep dive on a specific product.
Strategy and transformation. In today's fast-paced world, staying ahead means crafting strategies that are as dynamic and multifaceted as the challenges you face. The future of the enterprise needs to be reimagined, with the onset of AI and disruption to navigate complexities, risks, and opportunities. Introducing the AI-powered EY Edge Suite, a dynamic blend of deep sector data, decades of EY industry knowledge, and leading-edge AI technology. It's designed to create value and deliver results across 3 critical dimensions: strategy, transactions, and transformation. Whether you are navigating sector convergence and disruption, identifying growth opportunities, or executing transactions, the EY Edge Suite, powered by Microsoft, helps you design and deliver your strategic objectives at pace. EY Competitive Edge draws upon innovative AI capabilities to provide 360-degree insights on opportunities, risk, and resilience considerations to put at the heart of your strategic planning. EY Diligence Edge is an integrated suite of tools used across the transaction lifecycle, utilizing automation and AI to accelerate data review and analysis, surface key risks, red flag items, and highlight tailored deal insights. EY Capital Edge streamlines transaction and transformation processes using more than 30 purpose-built apps across engagement accelerators, leading practices, and methodologies to drive better outcomes. Our AI assistant provides immediate, actionable, and personalized insights to help propel your engagement forward. From strategic reassessments to portfolio reviews, buy and sell side deal strategies to post-merger integration, and transformation to value creation. The EY Edge platforms help you more confidently shape your future. Harness the power of the EY Edge Suite and confidently navigate strategy, transactions, and transformation.
So you saw our vision. So a typical M&A journey is consisting of 3 phases. First phase is you build the strategy, then you do a diligence, and then you execute. So I'll touch upon Competitive Edge. Competitive Edge is the product which focuses on strategy. It's fueled by data. It is powered by AI. So we are making the relevant data available to our practitioners and our clients. And using the power of AI, we are generating targeted insights which are actually delivering a lot of value to our people. So it's not only transforming the way they were doing their day-to-day job, but at the same time, the targeted real-time insights are actually giving them a competitive edge in the market. So how do we use it for our clients? So what you do is you can identify, you can look at the transaction, you can look at the trends, you can look at the disruptions, and a user is very able to quickly identify the potential areas of investment and partnership. Then within the suite, there are filters. You can apply multiple filters, and then you can very quickly arrive at potential list of companies. Because this is at the sector level, subsector level, so very targeted list of companies you can identify. Then within the tool, you are able to do a complete overview of ecosystem of a company, because there are in-depth understanding of the transactions and financial data. You can look at a company's entire supply chain, right from their suppliers to their joint ventures, partners, and even their customers. You can also look at the specific patents that are getting filed in that company's surroundings, in that sector, subsector. And you can also analyze the trends, the company filings. And we have given another feature where you can do a competitor analysis, where you can place 2 companies next to each other, and then you can do very detailed, very thorough analysis and build a strategy around that. So there are some capabilities that we have provided here. What you see at the bottom is a harmonized data layer that we have created. This harmonized data layer consists of mainly 3 layers. One is the external procured data. So you name any vendor in the world. So we get the data procured from our vendors, and this is very detailed transaction data, financial data, patent data, and then we augment that with EY experience, which is our past engagements of decades of our engagement with various clients, the thought leadership we have generated over the years, the surveys, the interview transcripts, which was always there, but it was not in a consumable format. So we have made that available, and then we further augment that with the public data, the data from the web. So things like news, company filings, employee insights. So all these 3 layers are provided to the user. Now, in terms of user capability, what we have given is the ability for the users to search between these various layers. You can augment, the way you want, you can query these layers. And then we have created a very harmonized single user experience where, just like GPT, you can, in plain English or natural language, you can chat and you can get insights right at your fingertips. Then this is the Strategy App Store, and we have built very sector-specific, topic-specific apps there. So for example, if you are working on private equity, there is an app for private equity. If you are working on sustainability, there is an app for sustainability. Some other features are you can upload a document, you can upload a URL, and you can query them in a secured manner. And at the same time, there is a collaboration facility where you can create a project and you can share artifacts between the clients in a secure manner. So I'll give you a quick preview of, to make it all real, what type of questions user can ask. And I will highlight on keywords here, and then I'll narrow it down to how we build it, and then how MongoDB, Cosmos DB for MongoDB, how it is actually helping us solve a fundamental problem. So what you see on your screen is the landing page. On top, we have created this create project functionality, which is essentially the collaboration space. Now, at the bottom, there are multiple apps. You can see 5 apps there, but we are building several apps. So more and more apps will get added there. At the center, you see an interface which is very much like GPT. So let's say the moment I click there, you see a panel that comes in, which shows external data sources and internal data sources. So the user can query. Embryonic is our harmonized data layer. You can switch between different data sources. You can go to the procured data layer. You can see perspectives, surveys, sector insights. There is another functionality called Find Expert. So there are 20,000 EY experts. You can name a keyword, and then you can find an expert, and you can reach out to them. And then there is this upload document and query capability. So I'll ask a few questions. So we'll start with a basic question. Where is BP headquartered? Now, what is happening there is a lot of happening behind there. There is a company matching algorithm that is in place here. So the intent is to find the headquarters of BP, and as you see, it has identified BP PLC. There is no ambiguity. It's not showing BP as blood pressure. There was no hallucination. So I'll ask another question. What is the ultimate parent of Facebook? Now, intent is finding the parent, and the company is Facebook. And as you see, it identifies Meta as the parent, no ambiguity. So now I'll ask a bit more insight-based questions. So I'll use both the data sources. And let me ask a question. What are the investments made by Pfizer in oncology? So the intent is to find investments. Pfizer is the company, and oncology is something related to cancer. And within seconds, as you see, the insights are generated. Now, it gives you a suggested list of questions. So let's say if I click on what is the divestment strategy for Pfizer, within seconds, you got the answer. I'll ask another question, which is, again, a test of a keyword. What are the top 10 vegan companies in the UK? Now, bear in mind, vegan is not tagged everywhere as vegan. So there could be plant-based stuff, right? So, but still, for an end user, it's able to understand and infer vegan. And what you see is the companies, and where we have the revenue, it's showing the revenue as well. All happening within seconds. So, which is definitely like, a game changer for our strategy practitioners and clients. So I'll show you how did we build it. So what you see in your screen is basically a view of our architecture. At the base layer, what you see is our OpenAI infrastructure on Azure. This is powered by EY.ai. And you see the data sources. The data sources are ingested, and we have created pipelines for structured and unstructured data. Then there is a data storage layer. And then there is an API layer, which eventually feeds into the front end. So now why? Why did we go for Azure Cosmos DB for MongoDB? Now, for the strategy practitioners, the main thing is relevant information and accurate information. If you are giving a client or a customer a view of inputs to build a strategy, you can't be wrong on data. It has to be accurate. Otherwise, they will lose faith on the data. So the problem that we were experiencing is the hallucination. So automobile in one part of the word could be referred as vehicle in another part of the word. Similarly, vegan, the keyword in our database is not everywhere tagged as vegan. There is plant-based food. There are things like soya milk, oat milk. So when we were generating those insights, we were not able to ground our model sufficiently to give the accurate information to our user. At that point, Azure Cosmos DB for MongoDB came as a rescue. What we did is we adopted an approach of tokenizing our entire data set. And what we did was we isolated distinct nouns and verbs, and we vectorized them into Cosmos MongoDB vCore vector indexes. Then the next stage was we leveraged Azure OpenAI functions calls, and that acted as an orchestrator where we deconstructed user queries into classified components. Now these components, specifically the nouns and verbs, were then directed into relevant function calls, retrieving the top results based on a defined cosine similarity score. So we were able to find the right keywords that actually fed into our SQL query formation, and then using OpenAI, we were able to summarize the results. So that's pretty much like how Cosmos DB came as the problem solver. And just to give you a sense check, so even for our very complicated queries, which are actually scanning millions of records and several terabytes of data, we have been able to get close to 20 seconds average response time, which is remarkable. So as I mentioned, it's an app store, strategy app store. There are a few more apps which are there, but if you want to know a bit more about it, then you can find me in the EY booth number 432, or there is this Microsoft Technology Experience Center just across the street. You can find me, and I can talk you through them. And if there are any specific, I can share the pain points, how we overcome them. So please feel free to find me there. Thank you.
Thanks so much, Bhaskar. Really great to hear about how EY is building these AI apps. It's really fantastic. Cool. So let's talk a little bit about some of the new features in Cosmos DB for AI scenarios. So those of you that attended Satya's keynote, or maybe the Azure Data breakout session yesterday, you may have heard that we are making, and we have made vector search and the DiskANN-based vector index generally available in Azure Cosmos DB. We're really, really excited to bring this technology to you, right? So for those of you who may not be familiar, Microsoft DiskANN is a state-of-the-art vector indexing algorithm that was developed at Microsoft Research. It powers software internal to Microsoft and software that you've used yourself, such as search in Office, Bing multimedia search. If you ever search for videos or for images on Bing, you've leveraged DiskANN under the hood without even knowing it. Now, DiskANN makes vector search at incredible scales very cost-effective with very low latency. And it does this through a sequence of operations. So first, when you insert your data into Cosmos DB, the vectors themselves are compressed through a quantization process. And those vectors are stored in RAM for really fast access. Now, the graph construction, the data structure of disk ANN, it's a graph-based index. That's stored on high-speed SSDs, which make up the backbone of the Cosmos DB infrastructure. And there's an efficient interaction between the compressed vectors in RAM during search and the full fidelity uncompressed vectors that are stored on these high-speed SSDs. And the result is you're able to leverage the low latency of this solution, but then also do this at tremendous scale and at high cost efficacy, right? Provisioning RAM is much, much more expensive than provisioning high-speed SSDs, and so this is sort of a secret sauce to how Cosmos DB is able to do very performant, high-scale vector search at very low cost. Now, with general availability, we have several new features and capabilities as well. So we have performance improvements that are rolling out to all Azure public cloud as I speak to enable lower latency vector search at enormous scales, and we'll see an example of that in a minute. We're also allowing configurable vector index and search parameters as well. So as you know, when you're conducting a vector search, there's always a trade-off between latency and recall, and the cost of your vector search, and we're enabling you to tune that trade-off for your application. We have new compatibilities with core Cosmos DB features like customer managed keys, point-in-time restore, continuous backup, and also fabric mirroring. If you want to mirror your data into Microsoft Fabric to do analytics on that data. Really powerful combination. And finally, we're also enabling the vector policies to be modified so you can experiment and change your structure without having to reinsert data or create a new collection. So let's see an example of this in action here. So I'm going to go ahead and switch computers. Perfect. So I'm going to show an example here in Python. How many of you do development in Python? Quite a few people. OK, cool. .NET folks? Nice. Java? Just a couple? JavaScript? Couple of them out there. Yeah, cool. All right, that's awesome. So I'm sorry for the rest of you, but this demo's in Python, but so bear with me. So what we're going to do is we're going to use the Cosmos DB Python SDK. We'll walk through a really simple example here. So I have a Cosmos DB, a single collection loaded with 100 million vector embeddings. Now, Cosmos DB automatically shards and partitions your data for you. Whoops, let me go ahead and switch here real quickly. Whoops. Give me 1 second. I need to. There we go. Apologize for that. Cool. So I've already gone ahead and provisioned this Cosmos DB resource. I have 100 million vectors spread across 8 partitions because Cosmos DB automatically shards data for you. So what we'll do is we'll just set up a couple helper functions here to execute a query across those partitions, right? So we'll run an asynchronous query. It's a little bit cumbersome in Python, but we're going to go ahead and execute this query. So we have our helper functions defined. And when we want to do a vector search in Cosmos DB, it's part of our natural NoSQL language that's really easy to use, right? So this is what an example of a top 10 vector search query looks like. I'm going to select top 10 documents. I'm going to project an ID. I'm going to project the vector similarity score as well. And then I'll order by the vector distance to take advantage of the disk ANN based index. So what we're going to do is we're going to go ahead and run this query, and we're going to look at some statistics that come out of it. So I can see the results come back, right? I can see my IDs, I can see my scores, and this is sorted in order of vector similarity. I'm using the Euclidean similarity metric here, so lower is more similar. And I can see the results came back really quickly. Now, I'm also going to print out some of the server-side statistics, right? So I can see that this executed in 46 milliseconds on the Cosmos DB backend. That's extremely, extremely fast, right? The RU charge was about 182 request units. So again, if I'm using Cosmos DB serverless, like in this example, it's 1 million request units for 25 cents, right? So this is the total cost of that vector search that I just executed here. So put another way, when you generate a vector embedding to do a vector search, this is about 1/3 of that price. It's immensely cost effective, even at very large scales. So that's just a simple example of how you can do vector search in Cosmos DB. I'll have some links to some solution accelerators and some code examples so you can actually try it yourself. So in addition to vector search, right, we're super thrilled to announce the public preview of full text search and full text ranking using BM25. So full text search in Cosmos DB is really this game changer, right? You can quickly and efficiently find keywords and terms in your text properties in Cosmos DB, leveraging a full text index. This comes with built-in text analyzers like tokenization of words, removing stop words to sort of remove noise from your searches, and also stemming, right? So if I am searching for a keyword, like for example, the word swim, I could find other forms of that keyword in the documents as well, like swam or swimming. So it creates like a very powerful way to execute these full text search and retrieve the right documents. Finally, we've also launched text ranking with BM25. BM25 is an industry standard for scoring text documents based on certain key terms or words. And the idea is that if a document contains more particular keywords or terms, it may be more important to your search. And so documents that contain a higher frequency of those terms, especially in relation to other documents, will be ordered as more important and therefore higher in your search results. Now, we're also combining this with vector search and announcing hybrid search in public preview. And the idea is that you can combine the semantic understanding from the vector embeddings in your vector similarity search, along with the text-based importance of BM25 to actually get more relevant results from your search than using full text search alone or vector similarity search alone. And you can do this really simply in Cosmos DB. Again, it's part of our NoSQL query language. It makes it really easy to combine the two together. So let's see another demo of this in action here. So I have a simple web application that we've set up. Again, it's written in Python. It uses Cosmos DB serverless. It's run using Streamlit and Azure Container Apps. I have a link at the end of this talk where you can go and view the code and try it yourself in your own subscription. So what we can see here is I can search a database, and the Cosmos DB collection that I've set up here contains movie information, right? So I can show you how to search for different movies in Cosmos DB, right? So for example, if I want to search for aliens and space battles or movies that have this in the description, I could run different searches here, right? So I could choose, say I'll choose my DiskANN base index, and I'll run a vector similarity search, and I can see that this query is executed. It took a really fast, really small amount of time, and it found these records, and I can see the vector similarity score projected alongside that. Now, I can also compare that to a traditional full text ranking using BM25, right? So this is vector similarity search, and I can compare this to just running a full text search and ranking based on that BM25 score. And what I can see is that the results look a little bit different, right? So it's not capturing the semantic understanding that's found in the vector embeddings themselves. It's actually just doing a keyword like matching, right? So I can see space here, I can see aliens. So I can find that there are keywords in these descriptions of the movies, and the ones that are more relevant are closer to the top of my search results. Finally, I can execute a hybrid search, and the hybrid search is going to combine both the vector similarity search and the text-based scoring to bring the most relevant results to the top, right? So it's like, for example, I can see Babylon 5 here. So this is actually a perfect movie given the search term that I had that I wasn't actually able to find in my top 10 vector search alone. So combining it with the text ranking, the BM25 text ranking, brought even more relevant results to the top of my search. Now, I can show another example of this as well. So I have a Jupyter Notebook here. Again, sorry, folks, it's another Python demo. The Python people will be happy here. So what I'll do is I'll show actually a couple different ways of doing search in Cosmos DB. So we'll go ahead and connect to my collection. So this time, unlike the last collection, I've already set up a Cosmos DB collection with thousands of scientific papers, right? So these papers have been the information's been extracted. The title, the abstract of these scientific papers, the content has been loaded into Cosmos DB documents, along with the vector embeddings that describe these documents. So I can search my documents for a particular phrase, right? So I'm going to search these scientific papers for quantum particles and electron interactions. And I can execute a full text search, and you saw the results come back real quickly, right? And so what I can see here is that some of the search terms that I was looking for are found in the abstract field here, right? So if I go up and look at the query that I executed, I'm choosing 5 documents. I'm rejecting some of the properties of those documents. And I'm using a where clause. So I'm saying where full text contains any, and I'm feeding in my string, my search string. So any of the words that are found in my search string are going to meet this criteria. And any of the documents that do meet this criteria are going to appear in my search results, right? So I can probably find a couple examples. Like, for example, the word quantum appears here, right? And so I'm guaranteed to find documents that are related to my search term. But maybe I want to do a little bit better. Maybe I actually want to find the more relevant results from my text search. And that's where we would use a BM25 score. And doing this is really easy in Cosmos DB. The query looks very similar, but this time, instead of a where clause, I'm going to order by the rank of our BM25 score, or our full text score. And again, we're going to do this on the abstract field of our scientific papers. So we can go ahead and run that. And what we'll see when the search results come back is we'll see that the documents that are returned are sorted by the BM25 scoring here. And we have a little bit of network issues. But so the results came back. And what we can see here is that the documents that are ranked more relevant by the BM25 score, right? So more of my keywords in the abstract, but also more of the important keywords in the abstract, are ranked higher in the results list, right? So I can see lots of information, lots of hits here for quantum. I can see a bunch of mentions of particle and more mentions of quantum, and et cetera, in the list, right? So now the results are sorted by this BM25 scoring, and I can have the most relevant text search results at top. Now we can compare that to my vector similarity search, right? And again, vector similarity search, really easy in Cosmos DB. We saw an example of this earlier. I'm going to order by the vector distance to take advantage of our DiskANN-based index. And I can see that the results are ordered by their vector similarity score. So this time we're using cosine similarity, so the results that are least relevant are at the bottom, and the results that are most relevant according to their similarity score are at the top. So nothing surprising here. Again, it executes very quickly thanks to DiskANN. Now we can combine the results together, right? So the query looks very similar to our vector search query, except this time we're ordering by the rank of the RF function. And the RF function will fuse together the results from our full text score, so our BM25 score, and our vector similarity score to give us more relevant results that's based on the semantic understanding that comes from vector embeddings and those embedding models, as well as the text-based ranking, the text-based importance from BM25. And so the results that we see here, right, they're not ordered by vector similarity score, because I can see I have a lower score that's ranked higher than this. But what we see scrolling up to the top is we see that like this article is actually very relevant to my search criteria, right? Not only does it have a decently high similarity score, but also I can see that the abstract contains tons of the keywords that I was looking for, right? Quantum, particle, interactions, two-particle scattering. So a really, really great example of how I can use text-based ranking and vector similarity search together in Cosmos DB. I can store all my data in Cosmos DB. I can store my vectors in Cosmos DB with my data and still be able to execute these fast, cost-efficient searches to find the most relevant data for my AI applications. All right, so we also have a lot of resources to help you get started using Cosmos DB very quickly and efficiently. The first is we have a new cross-platform emulator that's in preview today. It has even faster startup, faster performance. It works on Apple Silicon and on ARM, works on Linux, really fantastic. We've had a lot of asks for this from customers over the years, so we're really excited about launching this. It makes it really easy for you to develop applications with Cosmos DB on a local development box before you take it to the cloud. We've also launched a solution accelerator for document ingestion and processing and storing this data and making it searchable in Cosmos DB. We have tons of customers that have unstructured text data from PDFs, from documents, from images, and they build their own pipelines to bring this data into Cosmos DB so they could execute vector search on it. Well, we've launched this solution accelerator, and you can go and try it today. There's a QR code here as well. And this solution accelerator leverages Azure Functions, so it's another serverless application. Azure Functions is an orchestrator that will pull data from a storage account, your PDFs, your Office documents, and what have you. It will use Azure Document Intelligence to extract the text from those files. It will chunk the files for you, create vector embeddings using Azure OpenAI models, create data items, then insert them into Cosmos DB so you can search on them using vector search and full text search. So really powerful accelerator. Go on GitHub, give it a try, and let us know what you think as well. You could always send us some feedback at cdb4ai@microsoft.com. We've also recently launched our Cosmos DB samples gallery. This is the official source for Cosmos DB code samples, solution accelerators, technical guidance, and other content. I really encourage you to check it out. You can find all the materials that I talked about here and examples and other solution accelerators to get started. Don't worry, the examples are not all in Python. We have plenty of .NET examples. We have plenty of Java and JavaScript examples as well for you other developers out there. All right, so that concludes our talk here. We have a lot of resources to get you started. Again, we have a few AKAMS links that you can check out. We have a lot of other sessions at Ignite as well. You can come learn Thursday about the mastering performance and cost in Azure Cosmos DB. In breakout session 124, you can learn about how DocuSign innovates in their applications with Azure. We have a session tomorrow also on lowering your TCO, your total cost of ownership, for your Mongo workloads by using Azure Cosmos DB for MongoDB. And also we have 2 more lab sessions, a hands-on lab session for building a serverless application with Cosmos DB for NoSQL, just like I showed earlier today. And then finally, please give us a review on PeerSpot. You get $50. You can meet the PeerSpot reps just outside and at the expert meetup zone as well. And we'll be hanging out for a couple minutes here to take any of your questions and have a chat. So thanks a lot, everyone. Appreciate it.
Any questions from the group here? Cool, we've got some questions from online.
Yep, I think there's one question here.
Where are we at?
So does your recommendation, well, the samples and stuff, do they contain recommendations for how you're gonna should chunk your document?
Yeah, exactly, yeah. So actually in our documentation, we have some examples of some simple chunking strategies that you can use for chunking your text and vectorizing your text. And in the solution accelerator that I shared, there's a couple of options there as well, so you can go take a look.
Okay, we got some questions from online. One is from Suhel. Suhel wants to know, how should we decide if we should use Azure AI Search, Azure Cosmos DB for NoSQL, and recently announced vector storage and search on Azure SQL Server? They all seem to promise similar offerings, but uncertain what's best by different scenarios.
Yeah, that's a great question, right? So for Azure SQL and for Cosmos DB, there's reasons why you would want to use a relational database like Azure SQL, very powerful, want to keep my data in tables, want my defined schema. Whereas in Cosmos DB, it's a document store, right? So it's NoSQL, very flexible schema, very scales outward incredibly, has instant dynamic auto scale. So there are use cases of why you would want to use a relational database and a non-relational database, and those fundamentally don't change, even though both services offer a vector search capability, right? Now with Azure AI Search is a fantastic search service, right? They've been around for a while. They've developed this awesome full text search capabilities that are really complex. They have their semantic re-ranker. Azure AI Search is really good if you have data stored in multiple places and you want to index over those data in one solution, right? So if I have data in Cosmos and data in Postgres and data in SQL and data in Blob, and I want one indexer over those services, that's a great solution, right? And Azure AI Search does a great job there. However, if I want to use one database and keep my architecture very simple, if I want one highly scalable, high performance, high availability database, there's no better choice than Cosmos DB. And you can also do your vector workloads, your vector search workloads also in Cosmos DB as well. So there's different use cases and different strengths for each of the services. But if you have any more questions, like we can always have a chat. But Cosmos DB is a really great place if you want a single source of truth for your data.
Cool. We've got 2 more friends with questions. Let's get to the first one. And this comes from Eric McDonald. And Eric wants to know, can you use continuous backup with vectors?
You can now use continuous backup with vector search. Yep, it's new as of GA. So you can go ahead and use continuous backup. And this also enables you to do fabric mirroring as well.
All right, that's all of our questions.
Cool. Thanks a lot, everyone. Come see me after. Oh. you can always come up and have a chat with me. Thanks.